In this video, I want to show you how we can prove double-angle identities for trigonometric functions. For proving these identities, which are a special case for some formulas or some identities for trigonometric functions, we use the sum identities for trigonometric functions. Maybe you wonder why we have to learn the proof of these identities, because this is a good exercise for us to learn how we can derive these formulas or identities from the sum formulas. So this can be a good practice for us doing this. Let me remind you first the formula for the sum formula for sine. Sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. This is the formula that we have for some of the angles for function sine. You should be familiar with this formula. Sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. The double angle identity, this identity for sine, is a special case for this. This is more generalized than this. But how we can derive this formula here from this formula? Simply, if we suppose here alpha and beta, both of them, as theta, then theta plus theta, attention, here is a plus, theta plus theta would be exactly 2 theta, and we can derive that formula. So for deriving this formula from this formula, we suppose alpha and beta, both of them. So we suppose alpha equal theta, and we suppose beta also equal to theta. Then by doing this, we have sine of theta plus theta, which is 2 theta. Sine of 2 theta equals, look at the other side of the equation, sine of alpha, but alpha is here theta. So we have sine theta cosine of beta, but beta is also theta, plus cosine of alpha, alpha is theta, sine theta. Now look at this, sine theta cosine theta plus cosine theta sine theta. But cosine theta sine theta is the same as sine theta cosine theta, because in the multiplication the order of the terms is not important. So sine theta cosine theta plus sine theta cosine theta is in total 2 sine theta cosine theta, and this completes the proof of this. Sine of 2 theta is 2 sine theta cosine theta. Now for proof of this identity, we use the formula for cosine. For cosine of alpha plus beta, if you remember, we have this identity, cosine of alpha cosine beta minus sine of alpha sine of beta. Now, similar to the previous part, if we suppose alpha and beta equal theta, then we can derive the formula. So we suppose alpha equal to beta equal to theta. We suppose both of them equal to theta. Then by doing this, we have cosine of theta plus theta, which is 2 theta, equals in this expression replace all of these angles alpha and beta with theta, theta, theta everywhere. If we do this, then we have cosine theta times by another cosine theta minus sine theta times by sine theta. Cosine times cosine is cosine to the 2. Sine times y sine is sine to the 2 theta. So cosine of 2 theta is cosine to the 2 minus sine to the 2, which completes the proof of this part. But maybe you wonder why we have 3 formulas for cosine. Because from this relation we get only this formula for cosine. But where these formulas are coming from? Basically, these 2 formula which are equal to this, these are not new formulas. If you tweak this original formula a little with the Pythagorean identity, you can derive these 2 other formula easily. Let me show you how. By using the Pythagorean theorem, we can change this to this. But before that, let me remind you the Pythagorean theorem, the Pythagorean identity, not Pythagorean theorem, Pythagorean identity for trigonometric function. The most important and famous Pythagorean identity is sine to the 2 theta plus cosine to the 2 theta is always 1. From this identity, if we move this to the other side, we have what? We have cosine to the 2 theta is 1 minus sine to the 2 theta. And now, if we keep the sine to the 2 here and we move this to the other side, we have this relation. Sine to the 2 theta is 1 minus cosine to the 2 theta. Now we want to use these 2 relations to change this to these 2 other formulas that we have for cosine of 2 theta. Please pay attention. If we replace this cosine to the 2 here with this formula that we have for cosine to the 2, let's see what happens. So we want to substitute cosine to the 2 theta with 1 minus sine to the 2 theta. By doing this, we can write this expression in the form of 1 minus sine to the 2, because cosine to the 2 is 1 minus sine to the 2, and we have another minus sine to the 2 here. So we substitute this with this formula here. Now simplify this. 1 minus sine to the 2 minus sine to the 2 is 1 minus 2 sine to the 2. And this is exactly this formula. What about the other one? Here again, in this formula, let's substitute this. Let's replace sine to the 2 theta with 1 minus cosine to the 2. So we substitute this with 1 minus cosine to the 2. By doing this, this relation can be written in this form. Cosine to the 2 theta minus, we substitute sine to the 2 with 1 minus cosine to the 2 theta. Let's simplify this. Cosine to the 2 minus cosine to the 2 would be 2 cosine to the 2, because minus would be plus. So this equals 2 cosine to the 2 theta minus 1. And this is the other formula that we have for cosine of 2 theta. So as you can see, the cosine 2 theta is basically this, but this can be written in these 2 other forms. So this is not 3 formulas. This is basically 1 formula that is written in 3 different forms. Finally, now we want to prove this relation for tangent. Tangent of 2 theta is 2 tangent theta over 1 minus tangent to the 2 theta. For proving this, let me remind you the formula that we have to know for tangent of alpha plus beta. Tangent of alpha plus beta is tangent of alpha plus tangent of beta all over 1 minus tangent of alpha tangent beta. Now if we suppose alpha equal to beta, both of them equal to theta, then from this relation tangent of alpha plus beta is theta plus theta, because we suppose that alpha is theta and beta is also theta, so the sum of these two would be 2 theta. So we have tangent of 2 theta equals alpha is theta and beta is theta, so tangent of theta plus tangent of theta would be 2 tangent theta. This is for numerator. For denominator, we have 1 minus tangent theta, because alpha is theta, beta is also theta. Tangent theta times tangent theta is tangent to the 2 theta. And this completes the proof of the identity for tangent. Tangent of 2 theta is 2 tangent theta over 1 minus tangent 2 theta. Look at this. We proved the identity for tangent as well. As you can see, these type of proofs are not maybe really important, because just we have to memorize the formulas. But if you know where these formulas come from, it can help you to better understand, first of all, these formulas. The other thing is that if you want, you can derive them. I hope by watching this video, you have learned how to derive double angle identities for trigonometric functions.